Let us let us continue solid state. In the solid state, we will see regarding octahedral void. We'll take octahedral void. We'll see octahedral void. Now we will take about octahedral void in closed pactal lattice. We'll see. So first we will take this one layer. We will take one layer. We have taken. This is one layer. This is one layer in the first layer. You see this first layer. In the first layer, how it is there? See this particle. You see this particle. You are taking this particle. This particle is in contact with this particle is in contact with how many voids? You see 1, 2, 3, 4, 5, 6. This particle is in contact with one void, second void, third void, fourth void, fifth void, 6 voids. How these 6 voids will be present? This particle is in contact with it. Now, in this case, we can say each particle is in contact with 6 voids. 6 voids are there. Okay. Suppose if you take this particle, suppose you are taking this particle, it is in contact with how many voids? You see 1, 2, 3, 4, 5, 6. Okay. So we can say each particle is in contact with 6 voids. 6 voids. Now we will go for a second layer. We will go for second layer. In the second layer, due to second layer, what type of voids will be created? That we will see. Okay. So now we are going for second layer. Now here, this green color ball. This green color ball, we will take it as first layer. This will take it as first layer. Will take this orange color. Will take it as a second layer. This orange color we are taking as second layer. This green is this green color will say as first layer. This orange color will say as second layer. Sorry, 2 layers we said. 2 layers we said. First layer, second layer, like this. 2 layers are there. Sorry. Okay. Next, we will see void. We will see. Now we will take this green color. Will take this green color. Will take this first layer. This green color will take. This green color will take. This green color will take. It is in this green color is in contact with how many voids? Will see. That is first void here. Number 1. Number 2. Number 2. Number 1 we said. Number 1. Number 2. Number 3. Number 4. Number 5. Number 6. So 6 voids we said. We said 6 voids we said. Okay. This is number 1. Number 2, number 3, number 4, here number 5, here number 6. 6 voids we said. How these 6 voids are, how these 6 voids will be there? Okay. First we will take number 1. This number 1 will take. This first void, shall we call it as tetrahedral void or octahedral void? Sir, okay, we'll think it. Number 2, this number 2. Number 2, you see that number 2, how it is present means number 2 void is in contact with 3 green color balls of first layer and orange color ball of second layer. So this number 2 is called what means tetrahedral void. Number 2 is called tetrahedral void, we can say. Number 2 is called tetrahedral void, we can say. Then number 3. Number 3. Okay. Then number 4 we will take. Number 4 we will take. In number 4, how it is there, we will see. Number 4. In number 4, how the void is present. In the number 4, how the void is present, you think it. Then you say that which is better. You say the number 4 is fourth void is called what? Fourth void is called what we have to say. Fifth void is called what we have to say. Sixth void called wall. Sixth void is called what? Okay. Now you see this. First layer. You see this first layer we have taken. In this first layer, this particle will take. This particle is in contact with how many voids? Means 6 voids. 1, 2, 3, 4, 5, 6. 6 voids. That particle is in contact with the 6 voids we said. Sir, okay. Now we will see. Now we will take a second layer also. We will take first layer and second layer. We have taken we took a first layer and second layer we took. We took first layer and second layer. This green color ball is first layer. This green color ball is first layer. This orange color ball is second layer. Now we will consider this tick mark is a tick mark particle. We will consider. Now we will take number 1 void. This number 1 void, you see, this tick mark particle we are considering. Tick mark is green color tick mark we have considered. Void number 1 we considered. Void number 1, how it is present means. The void number 1, how it is present means. Void number 1 is present in first layer 3 green color balls. First layer 3 green color balls. And second layer these 2 orange color balls. Okay. So see the void number 1. See the void number 1. Okay. Tick mark particle we have considered. See the void number 1. This void number 1 present in 3 green color balls of first layer and 2 orange color balls. 2 orange color balls. In the second layer we will arrange next orange color ball. In the second layer we will write next orange color ball. In the second layer we will draw next orange color ball. Now you see number 1 void present in number 1 void is in contact with 3 green color balls and 3 orange color balls. Number 1 void number 1 is present in or in contact with 3 green color balls of first layer and 3 orange color balls of second layer. So void number 1 is in contact with 3 green color balls of first layer, 3 orange color balls of second layer. So void number 1 is called octahedral void. Okay. So void number 1 is called what? Means octahedral void. What do you say? What do you say regarding this? So void number 1, this void do you say octahedral void, do you say, or tetrahedral void do you say? Shall we say it is octahedral void? Why? Because why do you say it is octahedral void? Because this void is in contact with how many particles? How many constituent particles? 6 constituent particles. This void is in contact with, this void is in contact with 6 particles. This void is in contact with 6 constituent particles. Therefore, it is called octahedral void. So, now this tick mark particle is in contact with this second void. This second void is in contact with how many particles, that we will see. This tick mark particle, that means this green color, is having this number 2 void. Number 2 void. What about this number 2 void? That we will see. This number 2 void, if you see, number 2 void, this number 2 void is in contact with 3 green color balls of first layer and 1 orange color ball of second layer, isn't it? Number 2 void, you see, void number 2. Void number 2 we are taking. Void number 2 is in contact with the 3 green color balls of first layer and orange color ball of second layer. Yes or no? Void number 2 is in contact with the 3 green color balls of first layer and orange color ball of second layer. 1 orange color ball of second layer. So this void number 2 is in contact with 4 particles totally, shall we say? This void number 2, this void number 2 is in contact with 4 particles, shall we say? 3 particles from green first layer, 1 particle from orange second layer. So this void number 2 is in contact with 4 particles. So this void number 2 is called, which void do you say? This void number 2, do you say tetrahedral void or do you say octahedral void? Okay, you are saying that void number 2 is a tetrahedral void, you are saying. Sir, so you are saying this is a tetrahedral void. You are saying this is tetrahedral void, you are saying. Next we will take void number 3 we will take. This void 3 we will take. This void 3, if you see, this void 3 is in contact with 3 green color balls of first layer, 3 green color balls of first layer and 3 orange color balls of second layer. You see that? Now this void number 3, you see, void number 3. This void number 3 is in contact with how many green color balls of first layer, you see? How many orange color balls of second layer, you see? So now you say, shall we say void number 3 is in contact with 3 green color balls of first layer and 3 orange color balls of second layer? Then void number 3 is in contact with 6 balls totally. 3 green from first layer, 3 orange from second layer. Therefore, void number 3 is called what? Void number 3 is called, which void do you say? Do you say octahedral void or do you say tetrahedral void? Which void do you want to say? Okay, void number 3 you say. This void number 3 means this. You are saying that void number 3 is octahedral void, you are saying. Okay, for this tick mark, first you said this is called octahedral void. Number 1 is octahedral void. Number you said tetrahedral. Number 3 you are saying octahedral void. Next we will go for number 4 we will go. Number 4 it is this. Number 4 void we will take. This number 4 void is in contact with 3 green color balls of first layer. Number 4 void. Void number 4 is in contact with 3 green color balls of first layer and 1 orange color ball of second layer. You see that void number 4, you see this void number 4 is present in 3 green color balls of first layer and 1 orange color ball of second layer. So void number 4 is in contact with how many particles totally, you see? This void number 4 is in contact with 3 green color balls of first layer and 1 orange color ball of second layer. So this void number 4 is in contact with 4 particles totally. So shall we say this void number 4 is called a tetrahedral void? Sir, so we are calling this void number 4 is a tetrahedral void. This void number 4 is tetrahedral void. Next we will see void number 5 we will see. This is void number 5. This void number 5 is in contact with 3 green color balls of first layer and 3 orange color balls of second layer. Now see this void number 5. This void number 5 is in contact with 3 green color balls of first layer and 3 orange color balls of second layer. That means this void number 5 is in contact with 6 particles altogether, 3 green from first layer and 3 orange from second layer, totally 6. Therefore, this void number 5 shall we call it as octahedral void? So this void number 5 we will call it as a octahedral void. Then you say void number 6. What void? Void number 6 called. Now you say void number 6 is called, do you say tetrahedral void, do you say, or octahedral void, do you say, or some other void, do you say? Now void number 6 you have to say. For tick mark, for this tick mark means tick mark is given for this green color ball. For this tick mark, now we are seeing about void number 6. Now you say void number 6 is which void? Do you say, you are saying that void number 6 is called a tetrahedral void, you are saying. Sir, you are saying that tetrahedral void. Okay. You concluded that void number 6 is tetrahedral. Now we will take this tick mark. This tick mark is having number 1 void called this tick mark is having a number 1 void called octahedral void, number 2 void tetrahedral void, number 3 is octahedral void, number 4 is tetrahedral void, number 5 is octahedral void, number 6 is tetrahedral void. So this tick mark is having how the voids. First one is, it is octahedral means neighbor is tetrahedral. For this neighbor is octahedral. For this neighbor is tetrahedral. For this neighbor is octahedral. For this neighbor is tetrahedral. So for the green color ball, the tick mark green color ball is in contact with its above second layer. Now it is having how many octahedral means one octahedral here, second octahedral here, third octahedral here, 3 octahedral voids. For this tick mark green color ball, for this tick mark green color balls, 3 octahedral voids are there. Then how many tetrahedral voids we will see? This tick mark green color ball is in contact with its above layer called orange layer. Due to that orange layer, this tick mark ball has got octahedral voids and tetrahedral voids. How many octahedral voids means 3 octahedral voids we said. Now how many tetrahedral voids? You see one tetrahedral void here, one tetrahedral void here, one tetrahedral void here. Now this tick mark green color ball is in contact with its above layer called orange layer. Due to its above layer orange layer, this tick mark ball is in contact with how many tetrahedral voids? Do you see? This tick mark ball is in contact with how many tetrahedral voids? Do you say? How many tetrahedral voids do you say? This tick mark ball is green color ball. This tick mark ball is green color ball. It is in contact with this tick mark ball is green color ball. It is in contact with how many tetrahedral voids due to its above layer orange layer. Due to its above layer called orange layer, how many tetrahedral voids do you say? How many tetrahedral voids? Do you say 3? That is 1 year, second year, third year. So that do you say 3? Or do you say 4? Or do you say some other value? What do you say? This tick mark is a green color ball. This tick mark is green color ball. It is in first layer. It is in contact with its above layer, that is called orange color, orange layer. This tick mark ball, green color ball, is in contact with this orange color, orange layer. Due to that, tetrahedral voids are created. How many tetrahedral voids? That is one tetrahedral void here, one tetrahedral void here, one tetrahedral void here. How many do you say, sir? You said some answer. You said whether it is whether that answer is correct or wrong. Whether that answer is correct or wrong, you will say. So number 1. This is number 1. In that there is no doubt. This is number 2 tetrahedral void. In that there is no doubt. It is number 3 tetrahedral void, in that there is no doubt. Now you see here this point you see. Okay, now we will tick mark this tick mark void you see. This void is in contact with this green color ball in first layer and 3 orange color balls of second layer. 3 orange color balls of second layer. Okay, now you tick mark this tick mark void you see. This tick mark void. This tick mark void is in contact with one green color ball of first layer and 3 orange color balls of second layer. Therefore, this tick mark is called tetrahedral void. This tick mark is called tetrahedral void, we can say. So, this tick mark green color ball is in contact with how many tetrahedral voids, means your answer is correct, 4. This tick mark green color ball is in contact with 4 tetrahedral voids, you are correct. So, now you think and say this tick mark green color ball is in contact with its above layer called orange color layer. Due to that, this tick mark green color ball is having 3 octahedral voids and 4 tetrahedral voids, that you said, that is correct. Now we will go for which point? Now we will go for which point that you see. Now you see this point. Now each particle in a lattice, that means lattice means either HCP or CCP. CCP means FCC. Okay, each particle in a lattice is in contact with how many tetrahedral voids? How many tetrahedral voids? And how many octahedral voids? How many octahedral voids do you say? You have to understand that lattice. Lattice means what you understand very clearly. Lattice means what you understand very clearly. Okay. Lattice meaning is what is the meaning of lattice? That point you see. This is the lattice. Okay. You are given lattice is like this. Lattice means many layers are there. Lattice means many layers are there. If you take suppose this is one layer. This is a below layer. It is its below layer. It is its below layer. It is above layer. Like this it will go on continuous. Therefore, lattice means you have to consider above layer as well as below layer. So you have to consider above layer you have to consider and below layer you have to consider. So now we will see. Now we can say each particle in a lattice. Lattice means either HCP or CCP is in contact with 8 tetrahedral voids and 6 octahedral voids. You are correct. So we can say each particle in a lattice is in contact with 8 tetrahedral voids and 6 octahedral voids. What you said, that is correct. What you said, that is correct. Sir, okay. Next we will go for what means correctly FCC. Face centered cubic we will go. We will go for face centered cubic. In the face centered cubic, which positions are called tetrahedral voids, which positions are called octahedral voids, that we want to know it. So we are going for purely FCC. In the FCC, which positions are called tetrahedral voids and which positions are called octahedral voids, that we want to know it. Okay. So we are going for purely FCC. In the FCC, which positions are called tetrahedral voids and which positions are called octahedral voids? We will go for that. Okay. So we will go for tetrahedral voids and octahedral voids we will go. So now we will take this. Sorry, we have taken FCC here. We have taken FCC. Sorry, we considered FCC. FCC means corners will be occupied by constituent particles and phase centers will be occupied by constituent particles. Okay, so we are taking purely FCC. Okay, face centered cubic. In this face centered cubic means we have to keep particles in the corners. Okay, it is the first corner. I will take this is the first corner. This is the second corner I will take. This is the third corner I will take. Third corner. It is the fourth corner. Then it is the fifth corner. This is called a sixth corner. This we will take seventh corner. This will take eighth corner. Okay, 8 corners we mentioned. So we have gone for FCC, face centered cubic. In the face centered cubic means we have to keep particles in the corners. How many corners means 8 corners. In 8 corners we placed particles. Okay. Next we will go for face centers. Now this is a corner number 1 to corner number 2 to corner number 3 to corner number 4 again back to corner number 1 is called one face. For that face center is this one. This is a first face center. This is a first face center. Otherwise top face center. In the face center we placed atom, we placed particle, we placed constituent particle for FCC. Next, number 2 corner to number 6 corner to number 7 corner to number 3 corner back to number 2 corner. It is one face. For that face center is this one. For that face center is this one. At face center we placed a particle. Next, number 6 corner to number 7 corner to number 8 corner to number 5 corner and back to number 6 corner. It is one face. For that face center is this one. In the face center we placed one atom. In the face center we placed one atom. Next, number 1 corner to number 5 corner to number 8 corner to number 4 corner back to number 1 corner. This is one face. For that it is the face center. For that it is the face center. Then number 4 corner, number 3 corner to number 7 corner to number 8 corner back to number 4 corner. It is front face. For this front face it is the face center. For the front face we said face center. Then we will take back face. Number 1 corner to number 2 corner, number 6 corner to number 5 corner back to number 1 corner. It is back face. For that back face it is the face center. For the back face it is the face center. Now it is FCC. It is FCC. We have constructed FCC. In this FCC, tetrahedral void possible at which place? At which place of this FCC tetrahedral void is there? That we want to say. At which place of FCC tetrahedral void is there? At which place of FCC octahedral void is there? That we want to say. Where tetrahedral void is present and where octahedral void is present, that we want to say. So now we will take FCC we took. In the FCC where tetrahedral void is there, that we want to say. Where tetrahedral void is there and where octahedral void is there, that we want to say. First we will take tetrahedral. Now we have considered this FCC. In this FCC we placed at corners and at face centers we placed constituent particles. In this FCC we placed constituent particles at corners and at face centers. Now we want to say where tetrahedral void is present in this FCC. For that case, to say tetrahedral void, we have to take totally 4 particles we have to take. That 4 particles how to arrange means 3 particles like a triangle Above the triangular void, one particle we have to keep, then we will get a tetrahedral void. Okay, so to say tetrahedral void, what you have to do means first you have to take 4 particles you have to take. 3 particles you have to keep like a triangle. One particle, fourth particle you have to keep over this above this triangular void. Then you will get tetrahedral void. You will get. Then this void is called tetrahedral void. So tetrahedral void means that tetrahedral void will be present at the center of this tetrahedron. Tetrahedral void will be present at the center of this tetrahedron is called tetrahedral void. This is a tetrahedron. At this center, what is there means tetrahedral void is there. This tetrahedral void is there. So first we will see that means a tetrahedral void. If you want, we have to draw tetrahedron. We have to draw. Sir, to draw tetrahedron, we have to take 4 particles. We have to take. We have to take 4 particles. Okay. Which particles? Let us select. We will take 4 particles. Okay. Number 1 from face center. Number 2 from face center. Number 3 from face center. It is number 1 present at face center. It is number 2 present at face center. It is number 3 present at face center. It is number 4. It is corner. We have considered 4 particles. Okay. To say what? In FCC where tetrahedral void is there, that we want to say. To say tetrahedral void, we want tetrahedron. We want tetrahedron means we need 4 particles. How to keep 4 particles? 3 as a triangle, 1 above the triangular void. So we took 3 face centers we took and 1 corner we took. Let us join 3 face centers. Let us join 3 face centers. From this face center, you go to neighboring face center. Okay, 2 face centers we joined. Then you go from this face center to this face center. Then we have to go from this face center this face center. We connected 3 face centers. We connected 3 face centers. Are you getting triangle? 3 face centers we connected. Are you getting triangle? And 3 face centers, are they neighbors to each other or alternative to each other? You see, this face center neighbor is this face center. This face center neighbor is this face center. This face center neighbor is this face center. 3 face centers are neighbors. That means these 3 face centers are from one layer. This corner from above layer or below layer. Now let us join corner with face center. Let us join corner with face center. This corner with this face center. Next, we'll join this corner with this face center. Then we'll join this corner with this face center. Now you see, is it appearing tetrahedron? Tetrahedron means 4 equivalent equilateral triangles. Okay. 4 equivalent equilateral triangles means that is tetrahedron. Now, are you getting 4 triangles? 4 triangles are do we get or not? You see. Now, this is number 1, 1 to 4, 4 to 2, 2 to back 1. That is one triangle. Next, start from 2, go to 3, go to 4, come back to 2. It is second triangle. Then start from 3, go to 1, go to 4, come back to 3. It is third triangle. Start from 3, go to 2, go to 1, come back to 3. It is fourth triangle. So we got 4 triangles, therefore it is tetrahedron. Now, tetrahedron we got. That tetrahedron is present at where? Do you know? It is present in this small cube. It is present in this small cube. In this small cube, the tetrahedron is there. Have you got idea? You see this small cube. Okay. In this, it is actually one FCC unit cell only. For understanding, I am saying. In this small cube is there, no? That is front left bottom, small cube is there, no? In that small cube, this is one particle, this is one particle, this is one particle, this is one particle. We actually, if you say this is a small cube, this will become a corner. Actually, it is not corner, it is face center. For understanding, we said this is a small cube, like this we said. So now in this small cube, do you see tetrahedron? So in this small cube, one tetrahedron is possible, isn't it? In this small cube, one tetrahedron is possible means in this FCC unit cell. Okay, in this FCC unit cell, how many tetrahedrons possible? You say. In this FCC unit cell, how many tetrahedrons possible? The tetrahedron will see clearly like this. So this small cube is there, no? This small cube we will take outside. This small cube we took outside. Now in that small cube, tetrahedron is there. See, this is tetrahedron. This is tetrahedron. Okay. Now we will see. This is this complete. This complete is called one FCC unit cell. Okay, understand that this complete is called one FCC unit cell. In this one FCC unit cell, we considered one corner like this, and these three are face centers. Using this corner and these three adjacent face centers, we got one tetrahedron. This one tetrahedron is there in this small cube. Now the question is, in this FCC unit cell, how many tetrahedrons possible? One tetrahedron we have shown. So in this FCC unit cell, in which places and all we can draw tetrahedron? So how many tetrahedrons we can draw in this one FCC unit cell? In this one FCC unit cell, in which places we can draw tetrahedron? How many tetrahedrons we can draw? So how many tetrahedrons possible? That you say. Okay, this complete is called one FCC unit cell. This complete is called one FCC unit cell. Okay. This complete is called one FCC unit cell. In this one FCC unit cell, it is one small cube. In this small cube, we have drawn one tetrahedron we have drawn. Now, in this complete one FCC unit cell, it is not lattice. In a lattice, one unit cell it is. In this one FCC unit cell, how many tetrahedrons like this we can draw? How many tetrahedrons like this we can draw? You are saying 8